Artificial intelligence, the excitement, the uncertainties, what a time to be alive, right? We all feel it. It's changing our personal lives. It's affecting our businesses. And to do a test, by show of hands, who of you are in an organization who are developing systems that have AI models in them? Can I see your hands? Wow, okay. So this, taking into account the shy people, I think that's about 70% of you. And that's amazing. To me, having started in the AI industry in the beginning of the 90s, where this was almost 1% in that time. And I think next year it's going to be 90%. That is what we're talking about. And I think that you guys agree with me when I say that the effects of and the opportunities of AI are profound. Some say it's a revolution like the invention of electricity. Some companies report 30 to 40% efficiency gain, productivity gain. And in this case, this was about software development. So it's affecting our businesses, it's affecting our personal lives, for example, with voice assistants that are becoming better and better all the time. At the same time, there's also this. The microphones of the voice assistants, we don't always switch them on. I don't know about you, but I have them off most of the time. Because maybe it records. Where do these recordings go to? What if the model makes a mistake and sends my browser history to all my friends, for example? Or what if the model has been hacked and it does this? These uncertainties, we're dealing with that. So that's sort of the same thing, but a different perspective. And I think it's important that we have these two different perspectives and alternate between them. So the blue sky future and the burning earth future, if you will. So the negative perspective, what can go wrong? Now, we notice that our clients are also struggling. We're working with investors, for example, who are asking us, we want to invest in these AI startups, but we don't know if these guys are brilliant or if they put something together from the internet and pushed a few buttons. We're working with clients who are transitioning AI from the lab into the real world, where it suddenly needs to perform and be scalable and be documented, transferable, maintainable, secure, legal. So these are all issues. And we try to help these organizations with it. And for that, we built an AI readiness framework. And today, I want to take away, hopefully, some of these uncertainties by going through this framework with you as a blueprint for leadership when it comes to AI readiness. But first, in order to do that, I want to take everybody along. Maybe what I'm about to say about AI is familiar to most of you, but I want to take everybody along with what is AI. And what you see here is the most used definition these days, which is a system that infers from the input it receives how to generate outputs such as predictions, content, recommendations, or decisions. Quite generic. So if you have a lookup table that is based on data to make a decision, that's also an AI. Now, there are multiple categories, as you know. Within AI, nowadays, the most dominant category is machine learning. And let's look at what machine learning does. It's basically deciding on examples. It has seen a lot of examples on how to decide, on how to predict. For example, decide if a picture is a cat or dog. It gets presented a lot of examples of labeled pictures of cats and dogs. There's an algorithm that looks at the regularities, at the patterns there. And then another algorithm can use these regularities to look at a picture that it hasn't seen before and then make a guess and say, a cat. It's probably right in this case, but it can be wrong. It guesses based on new information, using regularities from the training set. And that thing on the right, the apply algorithm with the assumed regularities, that's the AI model. So this is machine learning. Now, within machine learning, there's a category called deep learning. Those are the neural networks. You probably heard about them. You're maybe even working with them. Those are very big, typically networks of very simple calculators in layers, and there are some similarities with the way the human brain works. Also machine learning. And within that category, there is generative AI. This is the ChatGPT, the large language models, the DALL-Es, the co-pilots of these days. This is where the biggest revolution is right now in generative AI. It's a type of neural network in its core. And in its core, it looks at examples, again, of text, and it finds the regularities. And what it does, basically, in its core, is predict the next word in a sentence. Now, this sounds like a very simple task, but in order to be able to predict the next word in a sentence, you need to have some understanding of the world. And this is what these models have. They see a lot of text, and they build up an understanding of the world that they use to finish a sentence or answer a question, which is a very similar task. Man's feline friend is coming in, and what's coming out is the cat. And if you have an advanced model, it will go on and provide you with some prose to talk more about the cat based on its understanding of the world. You recognize this from typical ChatGPT-like interactions. That's generative AI. Of course, you can use this for coding as well. We're going to talk a lot about this today. You can put code from the internet through it. It needs a lot of data, these models. And the big ones, they are very expensive to train. They cost millions of dollars to train. And they're so big that you cannot host them yourself feasibly. They have to be hosted externally in a very large data center, just to give you an illustration of how much is needed to gain this understanding of the world. This is about understanding coding. You present it with a lot of examples of code. The same setup, very large model again. What comes in is code that you're typing. You're creating a function to add values. And what it presents you with is the code finished. Very useful, but garbage in, garbage out, right? It works with code from the internet that isn't perfect, per se. And also, its understanding might not be how the real world works. But it goes a very long way. Still, the code that comes out of it is not perfect, just like the answers of ChatGPT, for example, are not perfect. Important to take into account. Now, to wrap up this 101 part, what are the roles of AI in IT and software engineering? There are, of course, systems that have AI models in them, like a loan application system or a face recognition system. And you can use AI to create software. So you can use, and we're going to talk about that, Copilot to help you code, or Code Whisperer, or Google Gemini. Explain code, very useful application of large language model, of generative AI. Verify code, like, for example, working through a lot of findings that you have, security findings, organize them, explain them to you. Verifying during development. Verifying during use, to defend a system using AI. This is a classic AI application where we're typically looking for patterns in network traffic or patterns in binaries to detect abuse, to detect malware. Of course, like any technology, you can use it for very bad things. You can use it to attack. And the most typical examples, and you must have read about them, is deepfakes and creating emails that are very tailored, and they help attackers to do phishing attacks. The last category is important. There's a wide category of AI systems that can help you in all of these processes by getting your questions answered. For attackers, how do I perform this attack? For defenders, how do I defend against it? For coders, how do I build an architecture that allows me to have a layered approach to authorization? AI can help you in approach all these things. Now, let's focus in the remainder of this talk on developing AI systems. You are creating a solution that has AI in it. What do you need to do as an organization? Well, step 1 of 3 is take responsibility. You really need to know where you are using AI, where you are building AI in order to control it. So you need an AI management system, just like you can have an information security management system. It has very similar characteristics. You can use the ISO standard 42001 for this. This was released last December. It hasn't been accepted in the Netherlands yet for all kinds of reasons, but I really urge you to have a look at it and to apply it, to create an inventory of your initiatives, to have a policy, to apply legal counseling, to involve your stakeholders. to look at compliance, look at the AI Act, for example, but don't be blinded by just the risks in the AI Act. These are about harm to individuals and society, super important, but it doesn't talk about the harm to your own business. Include that in your risk analysis as well. When you do the risk analysis, the impact assessment of your AI, you really need to do that first, before you start. Think before you start, because if you look at bias, for example, you might not be able to create the application without discriminating, which causes your initiative to fail. So these important elements for AI: bias, transparency, ethical applications, legal applications. There are a number of applications that will be forbidden. Like, for example, what I did in the 90s is criminal profiling with AI. On an individual level, that's going to be forbidden by the AI Act. And there are more examples of that. These things sound very daunting to arrange. Don't worry, you can build this on what you already have. You already have policies, you already have impact assessment, risk assessment. Just use what you have and extend that instead of appointing somebody and ask that person to set it up as a separate framework. We're seeing AI in isolation too much. Just build on your existing systems. You can assign a person, but that person needs to be lazy, because that person needs to work with everybody else in the organization to get it done. And then it isn't as daunting. If you're programming, treat AI what it is. An AI system is a software system, so you need to apply quality measurements, of course, versioning, unit testing, portfolio management, documentation. And these all sound like very obvious things, but we've looked at AI systems, and you can see here the blue dots in our entire benchmark, and this is research from last year that we did. And to be short, it clearly says very low maintainability in AI systems. And when we look at them, very little testing, very little documentation, security issues, privacy issues. Why? Well, data scientists, AI engineers, they are focused on creating working models. They haven't been trained sufficiently and not managed sufficiently to create models that need to work in reality. Now, how to solve this? Well, we solved this for you, and we built an AI engineering framework within SIG, and we donated this to an ISO standard that just came out around Christmas. A nice Christmas gift that shows the software system lifecycle with all the things that are particular for AI, and you can download this. It costs you €170. If your organization is not willing to pay this, then your organization is not ready for AI, and you need to start with some awareness first. Of course, you need to take security into account. That's also part of professional software. The way to do that is also to build on what you already have. Use the 27001, use your information security management system, and extend it. Add the AI security threats, controls, add those risks and AI-specific assets. And you can find everything about that at owaspai.org. It's also something that we started within SIG. It's an open source project about AI security threats and controls, and it feeds directly into standards for the AI Act and into ISO 27090. Wrapping up, third thing, very important, assume that everything will go wrong with your model. Assume that it will be hacked. Assume that it will make mistakes. Zero trust your model. Murphy's Law, basically, which means minimize the data that you collect, keep it as short as possible, and build in oversight by humans, by algorithms. If a self-driving car thinks it hears the driver say, open the trunk, don't open it if you're already driving. And continuously test, so limit your impact. And the complete picture is this one. You will get these slides, of course. You will see our AI readiness framework as we publish it in a couple of weeks. This is the main oversight. Use your management system on AI using 42001. Limit your impact. Treat AI for what it is, professional software. And extend your security by adding the relevant threats, building on what you already have in a collaboration between CISO, CTO, your GNC department, and of course the board that's where it needs to start, needs to see this challenge, and don't find it too daunting, but see it as an opportunity to get in control and to prevent all kinds of disasters along the way. And that concludes my talk. Thank you.
Great stuff. Thank you. So, one quick question before we move on. Yeah, you talk about using AI to build systems, but what about using AI to support programming? That's what everyone here wants to know. Sure.
Yeah, we're definitely going to talk about that. I didn't have time to talk about it. I'm looking forward to the panel where we're going to be discussing this. My view in it is that it's a beautiful technology that's going to help us to become more productive. And we need to be careful because people are lazy, and that's something that we need to embrace. And they tend to go for the short-term benefits. And that's a danger with AI coding for you, because you'll get code and then it looks good, you sit back and relax and okay, next problem, it passes all the tests. But that code needs to be of quality, and we talked a lot about that today. And if it's a lot of technical debt, AI is bringing us a way to very quickly create a mountain of technical debt. And I'm not saying that this will always be the case, but you need to have some discipline in your code review, in your process, more than you're having right now. To prevent sort of that lazy path of sitting back, relax, and let the AI do the work.
Right. We're going to talk about that in more detail later, I'm sure. So thank you very much, Rob. Cheers. Thank you. Thank you.